In this module, we shall state and prove that one step for the subgroup test. If S is a subset of the group G, then S is subgroup of G if and only if S is non-empty and whenever A, B belongs to S. A, B inverse belongs to S. Here B inverse is the inverse of B. Now we prove this result. To prove this result, we have to establish necessary and sufficient condition. First, we assume that AS is a subgroup of G. And we need to prove that A, B inverse belongs to S. If S is a subgroup of G, then S is non-empty. This is of course. And whenever A, B belongs to S, then B inverse belongs to S because S is a subgroup of G and S itself a group and it will satisfy all the axioms of group. So B inverse also belongs to S and by Closure property A, B inverse belongs to S. Now we prove the converse condition. Conversely, suppose that S is a non-empty subset of the group G such that whenever A, B belongs to S, A, B inverse belongs to S. Now we need to prove that S is the subgroup of G. To prove this, we shall verify all the axioms of the group being subgroup of G. Let A belongs to S. Then the inverse of A is multiplied with A and we shall get the identity element by using, we are just replacing B by A and we shall get this. And it implies that the identity element E belongs to S. So we have established the condition of existence of identity in S. Now we are moving towards the condition existence of inverse and we can multiply A inverse on both sides of this equation. हम इस equation की left side पे A inverse से multiply करते हैं, then we shall get A inverse equal to E A inverse because A inverse into A would give us E, the identity element, and you can see that it belongs to S. So we have verified that every element A belonging to S has its inverse. A inverse belongs to S. Now finally, if A, B belongs to S, then B inverse belongs to S because we have proved the condition of existence of inverse in S. So the inverse of B would belong to S. By the above and so AB equal to, we can write B inverse of B inverse as B. And you can see that A, B belongs to S because we are using the condition A, B inverse belongs to S. And we are just replacing B by B inverse. And we shall get A, B belongs to S in this way. And it means that we have established the Closure property for the elements of the set S in S holds. So we have verified all the axioms. It implies that S is the subgroup of G and we have gotten the desired result.